everybody. Welcome to your post-lunch presentation. I am talking today with Mazen about thinking fast, doing on-device vector searches and features. And again, of course, what is it? Another AI talk for you today. Just a little introduction. You already know a little bit about me. So get on the board. I wrote a TensorFlow JS programming book back in the day and got published in 2021. So you know I actually wrote it. It was before ChatGPT, right? And then I've been doing programming for a long time, over 25 years, and doing AI for at least 5 or 6 years now. And then with me is Mazen.
Hey everyone, thanks for coming. I'm Mazen Chami, software engineer at InfiniRed, YouTube and podcast host, and also all things React Native and father of 2.
There you go, fantastic. Woo! Wonderful people here. So thank you for having us here, and I want to make sure that everybody knows that this talk is for you. And I say that very, very confidently, because it doesn't matter that if you are into AI or if you're just getting started, you're into front end, you're into back end. The trick is here that this talk is talking about the future, and we're going to be building a little bit off of Jason's stuff that he did this morning, the keynote. But what a great job Jason did with the keynote this morning. Right, Jason Mays. And so that gave you a whirlwind tour of what is possible. But now we want to go ahead and we want to hunker down, look at some code, and then see what you can actually implement and why you should implement some of these features. So we're going to start off with talking about how data, which those of us who have been for a long time, was pretty boring, unless, of course, we're talking about lieutenant data, right? But we've been doing this for a while, and it was like, there's an app for that. You're going to find that product. Then it was, how fast can your website load? How fast can you get this information? Because every second it doesn't load, you're losing somebody. And now we're in a place where you're looking at MCP, you're looking at other pieces. How fast can we not just get information to the user, but how can we give them the exact information that they want? That's important. How do we find this data and bring it to them? And you know, that's the reason why we have databases. It's the reason why we don't have everything just sitting in flat files. Well, some of us do, but not what we're supposed to do. And we're getting this information to you nice and quick. And the key part of this is, like, let's go through the example. And we're going to use the classic database example. We're going to use SQL, right? And so let's say we're looking for the word red, okay? So you're going to go ahead and we're going to say, let's get a SQL query together. We're going to put some percent signs on either side of that. And then we're going to do a search with a select like. And then we're going to go ahead and grab red. But you all see where we're going here. The semantics are being lost because sometimes that's not going to get us all the data that actually makes sense. Like, we want to see, like, this shirt is scarlet. It should have shown up in the same results. Well, now what are you doing? You're creating array tables. You're doing some other aspects. How do we get these concepts encoded into machines? And with that, we get all these magical powers. So we want to find the concepts in a bunch of zeros and ones, right? And that's how we're getting information fast, and that's what we can utilize with AI, and that's what we're getting with these agents. We're using it with LLMs. We're getting this information together. So I want to talk about how people have structured this. Now, if you're new to vectors, this is going to be a quick candy wrapper around it. If you know a lot about vectors, this will be a nice refresher. But this example is like, let's take a look at words placed in a three-dimensional space in context to what they have to do with each other. And in this example, we have the sky, which is going to be one vector. We have wings, and we have an engine. So the bee doesn't fly that high, has wings, and doesn't have an engine. It's going to get a vector along that space. But then again, if you're looking at a helicopter, it does have an engine, flies pretty high in the sky, and that'll be over there. And judging by the distance of these, we can see how related some of these concepts are to one another by where we're putting them in this three-dimensional space. If we were to map that out and take a look at these, we would understand things in a context that is amazing. It's almost hard to perceive. As a matter of fact, there's algorithms upon algorithms in order how to perceive how these vectors are working together. But the reason they are so difficult is because we don't just stop at 3 dimensions. There's no reason to just stop there. We have computer programs. If it works in 1 dimension, it works in 2 dimensions, it works in 3 dimensions, then why don't we just go to n dimensions to go ahead and put context and understanding and words and images in a way that they can be consumed. And the result of that is we get this beautiful placement where vectors that are placed in space can be subtracted and added and bring you towards new concepts that make sense. For instance, if you have king and you were to subtract the vector for female, it would bring you over to around the same space as queen. And then if you take the vector for queen and you subtract royal, it would give you the vector for woman. And these kinds of concepts are encoded in our culture in different ways, and then we try to put the information in there and encode those for us. So that way, when we see these things in informational spaces, they actually make sense. And when you add them together in sentences or in context, we're getting more than that SQL query that brings us back a simple word or zeros and ones. And with that, we've got the advent of what's been coming through this with AI. Because with these features, you can create all kinds of ideas, like recommendation engines. I don't know whether you're a consultant or you work for a product company, but you could use probably a recommendation engine at your company. You're looking at vectors. How many of you raise your hand if you've ever Shazammed a song? Right? You wanted to know what song that is. Same concepts here. We're taking it down into the fingerprints of what makes it what it is, and then we can do a search. And it blew my mind so long ago that I was able to, this finds every single possible song. The concepts have been with us for a while, and we're seeing it more and more. So I want to say we're going to be exciting today. We're actually going to try to do a live demo for you with images. So we're going to see what images look similar to other images. And this is just one utility of vectors, right? Of using vectors on a device. And even more importantly, we're going to do this as an example where we show you this in a sort of I need to know what aisle this is store. So let's say you have a product, you're taking a look at it, you get a picture of it, and you say, hey, I want to know where this is so that I can go to the store and pick this up. Oh, look, it's on aisle 5. Or maybe you're trying to shelve things. There's a million different ideas that can kind of happen here, but this is one example that we want to do for you today. And so you might be a little reticent here and saying, okay, I'm worried about this, because what I'm going to have is I'm going to add this feature for people to go to the store and find their product, or I'm going to have recommendations. And this all ties back to what Jason was saying earlier. In the next 3 years, AI is coming to you on edge devices. It'll be in your browsers. It'll be on your phone. You've seen the chips that continue to come out. And it'll be in every aspect. It'll be on your IoT devices. And by having those intelligent decisions there, you're not paying a huge bill. You're not paying this insane bill because I wanted to look up a fork 475 times, right? None of that's going across. And then the other side of that is you're getting this privacy. You know, there was the app that used to age people's faces, and what happened with that one? It was sending your image of your face over to Russia. So what happens when you want to have these kind of contexts running on your phone? The third thing is, we all know this, round trip time is money. And we talked about how important it is to give people their information fast. So if it never even leaves the device, then you are going to be able to support this feature and be able to give it to everybody, and it's not even going to cost your company a single dime. So I think with that, we should start digging into our example.
Yeah, thank you, Gant. So here at Infinite Red, we put together a vector search database library for you all. And I think after this talk and conference, if you guys are interested in this, we might release it to open source one day, so come find us and we could talk about it. The objective of this library is so that you can make React Native development easy, and we can store and search our images through the native code that comes out there. So I kind of want to walk you through some code just so you see what this looks like. So on the screen, you're going to see a lot of code. Really, I want us to just kind of focus on this one line over here, where what's happening is we're triggering native code to take our product, store it in our SQL database. So if I were to go down into the native code, Gant earlier mentioned, why stop at 3 dimensions, right? So we're going to go even deeper. On the iOS side, we're using Apple Vision Framework, which is giving us a 768-dimensional embedding of our image. That image is taken, broken down into 768 dimensions. On Android, we're using TensorFlow Lite, but this also makes it 1,280 dimensional embedding. All this gets stored on the phone's local SQL database. So how do you pull this from the device? It's a simple SQL statement. It looks just like any SQL statement you would make. I think the only difference here is approximate vector distance. That's a specific function that we would use here for the search.
Yeah. So that's fantastic. If I'm breaking things up in there, if I were to say to you, there's an animal, and it is furry, and people use it as a pet, well, then that starts to narrow down the space. And I've just given you, what, 3 vectors, right? It's a common animal, and it has, like, slits for eyes. We're all thinking of, right, the same thing? A Filipino tarsier, right? No, cats, right? So we're looking at what we're doing here is that by just those 5 vectors I gave you, we've identified things. So we want to get the maximum amount of key information as we can about the image. Anybody who's done CNNs and done image processing knows you want to pre-process the image as much as possible before you're tossing it in so that you have clean and clear data, right? And garbage in, garbage out. So there's an extra step that we're adding here, which is we're going to add the idea of pulling the forefront image. We're going to segment that out and then cut away the background. And you're all familiar with this. This is something that runs deep in your browser. When you're doing a meeting, you say, blur my background. It's identifying you, and it's throwing away the rest of the information into a blur. But what's great about this, if we're trying to pick out what's going on, and we've got great accuracy, well, we can have better accuracy. We should definitely pull the image in a little bit more and throw away the background so that we have the predominant forward-facing image, so that we use AI subject segmentation so you can see what are the key parts of what I'm trying to take a picture of. And now our results shoot through the roof. These images are provided by MLKit, so thank you, Google, for giving us those. But yeah, let's pay attention to what's the prominent image in there, throw away the rest, because we're looking for, in this example, what is this product?
Awesome. So what you'll see here is some more React Native code. And as we know, image salience doesn't ship with React Native. As a React Native developer, I would have loved if that was the case, but that's not the case. So we're going to focus on this line right here, where we're going to open up like our trapdoor and dive into native code again and get this done. We're doing 3 things on the native side. Well, we're going to run our image through preprocessing for salience. We're going to then generate our embeddings for our preprocessed image. And then we're going to search our database using those embeddings, right? On Kotlin, Android side, it's the same exact thing, same steps. And just like you saw earlier in the image, this function is going to return an image that has been simplified for just the important parts, and the background has been removed for it. And now, for the fun part, let's see how this kind of transforms into a live demo. What could go wrong, right?
Did someone do a sacrifice to the live demo gods beforehand for us? Yes? Good.
All right.
What could go wrong?
So here's the application that we put together. React Native Vector Search is what we called it. I think you saw it earlier in the code. One thing to kind of start off focusing on here is you'll see at the bottom, database is empty. Basically, we need to seed our database. We need to initialize our database, and what we're doing while seeding it is we're putting together 5 sample products in here, just so it's not an empty database already. First thing I'm going to do is, you're probably all wondering why I have a cup and an apple here. I'm going to add a couple products. So let's start with our apple. It's a crispy apple, I think.
Yeah, we have Apple did not sponsor this, by the way. Just want you to know. We're open to it, though. Yeah.
So camera works, right? You see, John.
Hey, wave! There you are.
So what I'm going to do here is I'm going to take a couple pictures of this apple. Just getting a couple.
And as it's taking these pictures, it's going through segmentation, and then it's going through into the image feature set and being stored, getting ready to be stored inside the local database.
Right. So we're going to create this product. Okay. Now I'm going to go ahead and do the same thing, but for this cup. Cup.
Just so you know, we're not sponsored by cups, but we are open to it.
Aisle 12, how about that? Okay. Again, going to just take different angles of this cup. Just include some writing. Okay. So if you remember earlier from the code, we've created our object, created our embeddings. In this case, I'm using an iPhone, so we've created 768 dimensional embeddings for our images. Now, we're going to search for our product. So
now, hold on, Mazen. Okay? It takes a lot to do a live demo, y'all, right? So if we take a picture of this apple, and it comes back and it tells us it sees an apple. Can I get some applause from y'all if that happens? Is that yes? Okay, all right.
Can we get a drum roll then?
Drum roll, yeah. No! Wait, it did?
It did.
Hey!
All right. Let's try
You know
our
what?
cup.
We need another one. Can you do the cup?
We're going to try.
Let's do the cup. All right, here we go. Drum roll.
There we go.
Yeah! Love it.
Awesome. Okay, the sky's the limit here. There's so many different applications out there that you all can do, taking thousands, many pictures of your products for your customers. Just imagine you're a DIYer and you're trying to find that screw, that bolt at your local Lowe's. That's all possible via this product.
And so one of the things I want you to know is like, this is one application. How many of you are familiar with vectors, vector databases, the concepts there? How many of you feel like you learned a little bit about vectors and vector databases a little bit? Good. Oh, I like seeing that. Yeah. The ideas of what you could do with vectors and vector databases are very simple, and it's like a new form of a battery. It's a new form of electricity. It can go into just any kind of product and actually improve it. Do we have anybody from Amazon here? So I have an idea. And this is for free. Like, we should definitely talk about some of these ideas. But has anybody ever received a package at their door, and you get the photo, and it's like, it's been delivered, and you look at it immediately and go, that's not my door. You did not deliver it to me. I see nodding heads, yeah. And then you run around the neighborhood looking for that door. Like, is that it? Is that it? Why, when the person took a picture of it right then and there, didn't it load past pictures of my door and my neighbor's door, and then simply go ahead and say, hey, we're like 99% sure that's not the client's door. Stop, turn around, verify it, hit this button to go ahead and tell us if it's wrong. We'll move it to the training data. Like, this would cost $0 to add to DoorDash, Amazon, FedEx, anything like that, and it would run all on the device. You could do this with recommendations. You could do this with sounds. You could do this with any kind of product out there. There's a million applications for vector databases, and we're only scratching the surface. And the great part about it is, like, these are coming into the way where it's going to be cheap, plentiful, and useful, which means that businesses are going to ask for it, and then developers are going to be on top of delivering this. So it's coming our way no matter what. If you're ahead of it, then it's even better. But I think there's so many great applications to vectors and vector databases and AI. And what I really want you to do is I want you to come talk to us afterward at some point. Mazen and I work for the wonderful company Infinite Red. We are the React Native experts. That's why it's just easy for us to drop down into native code at any given moment and deliver these things. If you want AI on mobile devices, we're your people. If you don't want it on a mobile device, or if you want us to do something with a server, that's someone else. We'll refer you to someone else. But we are mobile phone experts, and we work on this all the time. That's why we build a demo just for a fun talk, right? So with that, there's a lot of opportunity here. I'm going to echo a little bit of what Jason Lengstorff said, is that you've got in these next couple of days the option to meet and connect with people who are ready to just talk your ear off about all the cool features that can go for your specific product. People pay a lot of money for people to go there. From experience, people pay for you to go talk about AI at their company. But honestly, you have it for free here today. This is our community. This is what we want to give back to. And you have amazing people here today. Please come talk. I want to say one of the people here is Javier from HAL9. Javier, can you stand up? Yay! Front row, man. Yeah. This man can make magic happen with AI. And then you can see we've got Jason. Jason, you back there? Definitely, you've already been talking to him. Round of applause for Jason. And you've got us here from Infinite Red. Seriously, please come talk to us at the breaks. We are very friendly. We come out to these things because we're nerds, and we want to nerd out with you all. And with that,
thank you.
No.